Good morning to all of you. Yeah, this is lecture number lecture. We will discuss about the significance of shape factor in radiation. What is shape factor? It is very important term which is generally used in radiation heat transfer. So, in order to compute the shape factor for a certain geometry arrangement for which shape factors or equations are not available, the concept of shape factor as friction of intercepted energy and reciprocity theorem can be used. The shape factor for these geometries can be derived in terms of known as shape factor of other geometries. The interrelation between various factors is called shape factor algebra. So this is a basic diagram of a simple geometry. Let us consider an enclosed with several cases. Consider ith surface energy leaving surface I must be intercepted by the other surfaces. So now for the calculation of the shape factor for specific geometries and for analysis of radiant heat exchange between surfaces, the following facts and properties will be very useful. So the first is the shape factor is purely a function of geometric parameters only, and when two bodies are exchanging radiant energy with each other, the shape factor relation is given by this equation AI EI. So in general summation of I is equal to 1 to I is equal to n AI Fij EI, where energy received by the jth surface as AI Fi EI and the energy received by the surface is 27.2. When the radiation eliminating from concave surface 1 intercepted by enclosing surface 2, the shape factor of a convex surface with respect to the enclosed F12 is generally unity. So enclosed view factor 3 equating these energies represented in expression 27.1 and 27.2, AI EI is equal to summation of AI Fij EI is equal to AI EI summation of Fij, where Fij, the summation of Fij is equal to 1, or we can say the summation of the shape factor from one surfaces to all another surfaces should be equal to 1. This is known as summation rule. This summation rule is generally used to calculate the shape factor from one surface to the another surfaces. So for a flat or concave surfaces, the shape factor with respect to itself is generally 0. So for a flat surfaces, F11 is equal to 0. So F11 is equal to means the shape factor from the shape factor of a body 1 with respect to itself is equal to 0. This is due to the fact that any part of the flat or convex surfaces one cannot see any other part of the same surfaces. So this is a summation rule. Consider an imaginary surface E that will close with two surfaces in a big enclosure. Mathematically, F11 plus F12 plus F13 plus F1E is equal to 1. It means the summation of one body with respect to all the other bodies is equal to 1. For a flat surfaces, F11 is equal to 0. So equation 27.2 is rewritten as F11 plus F123 plus F1E is equal to 1, because F123 is equal to F12 plus F13. So if the two surfaces A1 and A2 are parallel, this is the condition. If A1 surfaces and A2 surfaces are parallel, then radiation occurs across the gap between them, so that A1 is equal to A2 and all radiation emitted by one falls on the other, then F12 is equal to F21 is equal to 1. So it is a mathematical expression. So in general, let us now the case of enclosure in which the one surface is exchanging radiation with respect to all of the surfaces in the including itself. If it happens to be a concave surfaces, this is because a concave surfaces can see or view another part of it. So mathematically f11 plus f12 plus f13 is equal to 1, f21 plus f22 plus f23 plus f2n is equal to 1, and fn1 plus fn2 plus fn3 plus fnn is equal to 1. So for enclosed factor 6, however, note that f231 not equal to f21 plus f31. If f231 is required to, even if f21 and f31 are available, one needs to first evaluate f23. This is a radiation heat exchange between the two bodies. So what is radiation heat exchange between two bodies? There are three terms is very important for radiation heat exchange. The first one is irradiation, the second one is radiosity, and the third one is absorptivity. So these three terms are very important. So what is irradiation? Irradiation means the total radiation incident on a surface per unit time per unit area, and it is denoted by the term G. And radiosity, the total radiation leaves the surfaces per unit time per unit area is known as radiosity. So for a opaque body, the transmissivity is equal to 0. So mathematically the radiosity is equal to epsilon EB plus rho G, where epsilon is equal to emissivity and EB is equal to black body power, emissive power of a black body. So if we talk about the opaque body, transmissivity is equal to 0, then rho is equal to 1 minus alpha, and it is equal to 1 minus emissivity, because as per Kirchhoff law, as absorptivity is equal to the emissivity. So mathematically J is equal to epsilon EB plus 1 minus epsilon multiplied by G. So 27.7 equation is the equation which is used to calculate the radiosity in terms of black body power and emissivity. So next is radiation exchange between the non-black surfaces. So net energy leaving a surface is the difference between the radiosity and the irradiation. So the heat loss, that is Q by A, is equal to J minus G, where J is equal to the radiosity and G is equal to the irradiation. So putting the value of G in this equation, so J minus epsilon EV divided by 1 minus epsilon. So on solving this equation, Q upon A is equal to EB minus J divided by 1 minus emissivity divided by emissivity. So if we correlate this equation 27.8 to the Ohm's law, so as per this equation, EB minus J is known as the voltage difference, or in case of conduction, EB minus J is equal to the temperature difference. So if we draw the radiation heat network as similar to conduction heat network, there are two nodes point. The first point, that is EB, and the second point, that is J. But in case of conduction, EB replaced by higher temperature T1 and J is replaced by the lower temperature T2. So but in case of conduction, in case of radiation, the nodes are EB and J. But 1 minus emissivity divided by emissivity is known as the radiation resistance of the surface. There are generally two resistance are developed in case of radiation. The first is known as surface resistance, and the second one is known as space resistance. So 1 minus emissivity divided by emissivity multiplied by A is known as the surface resistance in case of radiation. Next is radiation network. If we talk about the radiation network, consider two bodies which is maintained at different temperatures, T1, T2, T3, etc. So two or more surfaces essentially interact through the radiosities. The total energy leaving from 1 and 2 and intercepted by the surface 2 or 1 respectively, J1 A1 F12 and J2 A2 F21, where J1 J2 are the radiosity F12 and F21 is equal to shape factor of the two bodies. So the net heat exchange between the two bodies, that is Q12 is equal to J1A1 F12 minus J2A2 F21. So solving this equation, J1 minus J2 multiplied by A2 F21. So Q12 is equal to J1 minus J2 whole divided by A2 F21, or apply reciprocal theorem, J1 minus J2 is equal to 1 divided by A1 F12, because A1 F12 is equal to A2 F21. So the radiation network is drawn. EB1, EB2 are the higher temperatures and the lower temperatures points. So there are three resistance. The first and last resistance is known as the surface resistance, that is 1 minus emissivity 1 divided by epsilon 1 A1, and 1 minus emissivity 2, and between the two surface resistance there is another resistance is known as space resistance, that is known as 1 upon A1 F12 or 1 upon A2 F21, and the nodes are J1 J2. So mathematically the final expression of the heat transfer between the two bodies, non-black bodies, that is EB1 minus EB2 divided by two space resistance, and first is surface resistance. So next is radiation network. Radiation network between the non-black surfaces 5. Perfectly insulated surface can also participate in the radiation process and typically called radiating surfaces. However, J is equal to EB, since current to surface is 0. That is a perfect insulator, radiates whatever energy is incident on it. So this is a basic diagram where two surfaces are maintained, hot surface and cold surface. In between the two surfaces, shields is generally used. This shields is known as radiation shields. The significance of radiation shields is to reduce the heat radiation between hot surface and cold surfaces.